Hello friends, welcome to Data Pandit. As part of AWS tutorial series, I am going to talk about Amazon Redshift today. Amazon Redshift is a data warehousing uh, equivalent service in the AWS set of services. So mostly technically, if we compare this Amazon Redshift with any other database, it's the most similar to PostgreSQL Server database. So mostly the architecture matches with the PostgreSQL in terms of architecture, and more or less it is similar to all the many SQL databases like other commercially commonly used databases like Oracle or open source databases, you know MariaDB or DynamoDB, and MySQL database, and the native Amazon Aurora database, and uh, and PostgreSQL is more closer to the Amazon Redshift in terms of architecture and all, and MS SQL Server. So these databases which I have talked about, right? Oracle, SQL Server, and all. So syntax wise, I mean, because when we talk about the cloud provided services, and then we have a obvious question in mind that how the existing system which are running on premises, how we migrate or how we move those databases or move those data to the Amazon Redshift or any cloud services. So, if we talk about the list of databases which are popularly used and known, which are Oracle, SQL Server, MariaDB, MySQL databases, and DynamoDB. These can easily, communicate with this Amazon, Redshift, and we can pull, as part of AWS migration services. This can be easily connected, and lift and shift operation can be done. So let's talk about the agenda of the today's video session. So first we are going to see the architecture of the Amazon Redshift, how different components of Amazon Redshift, are residing as a physically residing, and how they are going to communicate to the outer world, and how internally they are going to communicate different components within the Amazon Redshift. This is first part, and second one we will be talking about the important features while comparing it with the another different databases or different data warehousing services. And we will compare the performance wise and cost in terms of cost, and how scalable it is, and what are the availability features, how secure this Amazon Redshift is, flexibility, and the data migration services. This is first part, the theoretical part, and then we are going to see the hands-on steps. I'm going to create a class Amazon Redshift cluster, and within that we are going to connect it to the SQL workbench. We are going to pull the data from you know Amazon S3 service, and within that we are going to create IAM role to to communicate with Amazon S3 via cluster, and we will establish the connection between SQL workbench and this Amazon Redshift cluster. Okay, we will going to create few SQL queries and all. So let's talk about the architecture of the Amazon Redshift. So Amazon Redshift is a data warehousing service. Okay. So if you look at this rectangular, which I encapsulated structure, rectangular structure, which is you know which is there, So within that there is a compute node and leader node, and this rectangular structure is called a Amazon Redshift cluster. Okay, and it's so in Amazon Redshift cluster there would be a first is Amazon Redshift cluster is whole everything will be under that Amazon Redshift cluster, and within that okay, within that there are leader node and compute nodes. So leader node will be communicating with the external client applications. Like I said, we are going to check the connectivity of MySQL workbench with the Amazon Redshift cluster. So so a leader node we would be the first point of contact for the external applications, client applications, and leader node then would be connected to the different compute nodes. So there are different functions for compute node and leader nodes. Okay. So the connection would be established using the ZDBC driver and the ODBC driver. So uh, any of the these available drivers, we could pick and choose and can communicate with the Redshift cluster. Okay, and then we are going to see through the ZDBC connectivity after this theoretical session. Okay, and there are connection is getting established to the external system via ZDBC and ODBC driver, and the cluster would be containing if there is a only one node, if we are creating the cluster for one node, then there won't be a leader node. If it is a two or more nodes we are going to create when we configure the cluster, Amazon cluster, Redshift cluster, then there would be a leader node and then there will be a compute node within that. Okay, so what is the functionality of the leader node? So whenever, so first of all, it establishes the communication between client applications, external applications, and the Redshift cluster, and also and through that component will be communicating to the leader node. Okay, and second major functions of leader node is whenever any query is fired to the Amazon Redshift data warehouse, then the execution plan and the compilation of that query would be done by leader node, and then the distribution of the sending of that compiled code to the among the different compute node, and also the the portion of data, like we have 10 millions of record which is going to be affected by the fired query, then 10 millions of record would be distributed among available compute nodes, and the compiled and parsed query, which has been sent, through the client, would be sent to the compute node. And then after, whenever compute node completes their processing, and they are going to send the result back. So the aggregation of the results would be done by the leader node, and send back results sent would be sent back to the user. So so this is the kind of map reduce structure if we compare with the Hadoop or big data applications. So this is mapping and then reducing. So we allocate the work and allocate the memory, allocate the work to the different compute node, and then after the query results comes, then aggregation will be happening and result will be returned to the user application. Okay. So if we talk about the compute node, there would be many compute node to perform the actual execution of the query. and there would be a separate CPU allocated to the compute node and memory allocation and the disk storage for each and every compute node. And there will be something called node slices. So within the compute node, there will be a multiple node slices, and the distribution of the work is done, equally among different node slices. Okay, and after the work is done, then the computation of the result would be done in within the compute node, and then it would be sent to the leader node for a final aggregation. Okay, so the number of slices within the compute node would depend upon the size of the node. What size of the, what is the size of the particular compute node is, that would be the deciding factor of the number of slices. So, okay. So this is the whole structure of the Amazon Redshift. Okay. So if we talk about first feature, let's talk about some performance aspect, and so if we talk about this Amazon Redshift with any other cloud services, or probably the on-premises service or different RDBMS, data warehousing services, then it's a very very high performance services. Okay, because it's going to be working, massively parallel processing. If we call it, we calling, right, MPP services, massively parallel processing. So what is going to happen is, leader node would be allocating the work to the different compute node, and those compute node would be parallelly would be working, and within compute node the different slices would be working parallelly. So it's a kind of massively parallel processing system. And then there is a, columnar structure actually. So columnar storage, so this is a very effective aspect of, storage and the computation frequency, computation in terms of computation and the memory requirement. So normally the data would be a row-wise, storage, but uh, similar to many databases like Santara and other databases, right? This too has a, columnar structure. So it will be so the file system. If we talk about the Parquet file system and, ORC file system, those file systems are also columnar storage. The benefit of columnar storage is the actual data would be stored, in a columnar way, and this being the OLAP engine, all the queries would be OLAP queries, because it's the data warehousing application. So the OLAP query would be needing the results from the one or two columns, among many columns of the particular tables, or, different tables. So because we are not going to, need the entire row for a particular query. So if we fire the query through for the columnar storage, so all the columns would be, stored in a same place. Storage will be happening in column storage, like first column and then second column and then third column. This is a columnar storage. But in the row wise storage, what is going to happen is the storage will be happening in the blocks, and then in the first block, first record will be getting stored in entire all the column in sequence, and then the second record, and then the third record. So when we fire the OLAP query, so OLAP query, because we are getting the aggregate based on some columns, right? Or couple of columns, or maybe two or three columns. So that we are going to hit one or two columns, but the entire, all the rows vertically. Therefore the service would be very faster, because all the columns, stored in the same place. All the data of the particular column would be stored in the same place. And the second benefit of columnar storage is compression, because the similar data is placed at the one place, then the compression would be very easy, right? So in terms of disk storage and the retrieval of the data would be faster. And this makes it a very high performing data warehousing application in terms of in terms of processing. Okay. Then there are query optimizers. So if we have multi joins and different sub queries, and there are many aggregation queries, then there is a specific optimizer in the Redshift, Amazon Redshift. So that would make make the query query engine very fast in terms of getting the result for the different complex queries. Okay, and then there is a optimizer, opti- query optimizer. Okay, and then there is a result case. Okay, so what is the result case is? So it's a very intelligent system. So the leader node storing storing the some result for the prior queries. So if the similar request is coming and it is matching exactly same, then that case would be the query would be served from the leader node itself. It won't go to the compute node. But there are different factors. First of all, we can disable the caching if we want the real time results, or we are saying that the data warehouse has been updated and we want the current and real time result from the data warehousing. Then we can disable the caching mechanism. But most of the cases, because the data warehousing database would be a very less frequent updation, right? Maybe once in a day, or probably weekly update. OLAP engine, OLAP databases, if you know the data warehousing application, they are not like OLTP systems, which data is coming constantly and they are getting updated. So data warehousing application therefore will be optimized for the read purpose. They are not optimized for the write purpose, right? So in that respect, result case is very effective for the servicing of the queries. Okay, and the compiled code, all the compilation is happening happened at the level of compilation of the queries and parsing things, and that's execution plan. Those mandatory and one of things would be happening at the level of leader node. So compute node doesn't have to worry about those which is the optimum path, or what is the what needs to be done. A compute node should not be worried about. So in that respect, it's a very fast and it's a very convenient to for the computer node to perform the task. And there would be a different compile code for if we have, because it could support many connections at a time. The Amazon Redshift, it could be a parallel connection for ODBC drivers and the JDBC connectivity. So there will be a different compile code sent from the leader node to the compute node for a different client applications, right? So this is performance wise and the cost. So if we talk, it's all depends on the requirement. So whichever what big node, or the size of the node, and what we are going to store. So the cost is dependent upon those factors. But normally, if we compare generally with all the other data warehousing applications, or on-premises as well as the cloud applications, the AWS Redshift is winner in that. So, and it's very cost effective and cost friendly for the clients. So therefore, I mean, Equinox, Pfizer, Philips, and MACD, those big organizations are using Redshift clusters massively. And other there are tens of thousands of customers which are started using Redshift as a their data warehousing services. Okay, so this is about the cost, less costly. Okay, and scalability because it's one of the feature of all the services across AWS services. So scalability is going to happen automatically, and there would be a control to the user that whichever way horizontal or vertical scaling, scale out, horizontal or vertically. Any number of nodes as required can be added into the cluster, and can be reduced from the cluster. Okay, and there is availability. So in terms of availability, the cluster could be replicated on another availability zone or another region, right? And snapshot can be created, to restore the things, in terms of this feature, can make it more available and as well as flexible in terms of its connector, and it can be integrated to with many services, you know and in terms of adding the storage, and there are many things which makes it very flexible. Okay, and then there is a database migration. So in the earlier talk, I was talking about the different databases, right? And the connectivity of this Amazon Redshift with the other native services and also the external services. So if we are talking about the native services, so we can connect this Amazon Redshift with the S3 bucket, which we are going to see in demo, and we can copy as much data from the S3 bucket to the Redshift cluster, and do the query. Okay, and then there is a Amazon DynamoDB. We can connect Amazon DynamoDB, and we can use the copy command and get the data from Amazon DynamoDB to the data warehouse Amazon Redshift cluster, and perform the different query and get the analytics out on and about those data. Okay, then there are Amazon EMR, Elastic MapReduce application services for from the Amazon native services, and EC2 instance, right? So we could SSH to these applications and get the data from these applications into the Amazon Redshift, and can do the analysis. Okay, for that particular data. And another aspect is Amazon data pipeline, right? So if we have established Amazon data pipeline already, and we want to pull the data from Amazon data pipeline, then there is an easy connection between these two applications. Okay, and then there are commercially available and popular databases like Oracle SQL Server, PostgreSQL, Amazon Aurora, that is a native to Amazon database. Okay, and MySQL. These databases can be easily connected with the and Amazon Redshift, and data would be migrated from these databases to the